should be live. Let's just double check. Double check my sound. Sounds good. Perfect. Perfect. Early. A few minutes early. What the heck? There's some people on. And I'm going a few minutes early because I just realized that, dang, I got to alter and print another part. But it's just a small part, so it should be able to print at the beginning of the stream, no problem. And I'll explain to you kind of what's going on this screen over here. No intro. I know it's weird, but we just jump right into things now, and I'll explain to you what we're doing and a few things that got to take care of. But in the meantime, yeah, we just started a tad early because I felt like it. So, what the heck? Let me double check something over here with this piece. How's everybody doing, by the way? Love it when they shrink wrap a bag crooked and it doesn't open properly. Hello, 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 hello. Who's on? Let's see who's on. You are early. I am early. What the heck? It can't hurt to be early. I'll just we'll just shoot some BS while we wait for everybody. But this stupid thing doesn't seem to be. Nereus came on yesterday. We talked about the flashlight. Cool. Very cool. Hello, everyone. Okay, so who's here? Let's just see. I was first. I was second. Jerry is always right up there. So, hey, Jerry, how are you? And then Tintalon is here, and Ranch Kid, and Petty Ruxpin, Wiki Central, and Jerry. News came on, talk about. I'm excited about getting this flashlight built, and I have all the components for it. But I'm not going to rush it because there's a few things that I gotta figure out yet. But hey, we're going to start doing some soldering and stuff. Build It Basement. Hey, how are you, Kermit? I haven't seen you in a while. So how you doing? Okay, where are my scissors? I need to cut open a bag here. I want to check something. We got two things we're going to work on. We got the Forever Flashlight designed by Chris, or Neres as he's called on YouTube. And we have some, now Chris also did a battery, a power bank, but this is a different person's power bank. And I had ordered these things, these parts for it prior to seeing Chris's. And I may eventually do Chris's power bank because I do believe his power bank also uses these massive batteries in his power bank. So we're gonna look at both options here. So this is exciting territory for me. So anyways, I'm just checking out one of these electronic pieces here real quick. I do find on some of these, I have to trim the little solder tips off here because they tend to get in the way of the printed part. So we're just gonna snip a few little tips of these things off. There we go. And then I'm gonna I just want to test something here and see. The fit should be good, and I'll show you exactly what I'm doing here in a second. I might alter that just a little bit as I go here. So anyways, as I say, we're going to work on two things here. We're going to work on the flashlight. We're going to get some stuff started on it tonight. And we're going to work on these power banks. And I'll show you the video I watched as far as these power banks go and where I got the idea. So let's see, Nick is here as well. Tulsa Skin is here. Lots of people here. How many? We have 13 already. Little bit of house cleaning, housework, whatever. Anyways, up in the upper pinned in chat, excuse me, is a link to the Polymaker draw. As usual, enter once. I will check this time on the spreadsheet. Go ahead and enter the Polymaker draw. I've pinned it in the link and pinned it in the chat, and it's also in the somewhere, wherever the description of the video is. There's a link to it as well. So go ahead and do your thing. So, and enter. And it looks like I've already got 7 entries. So you guys know all about it. Just go ahead and enter as per usual. And in the meantime, we'll go over these things. So you guys all know I've talked about this on the last few streams about the Forever Flashlight designed by Chris Neres. So I haven't put a link to it, but I can put a link to it. But I'm going to go, I'll put a link to it right now, and then I'll show it to you. Command C. I will come in here and I will go Command V, and here is a link to the flashlight we're working on right right there. Okay, so there it is right there. It's in the chat. That is the link. Okay. So for those of you that haven't seen it, it is right here. It is in printables. Let's switch over to the display. So it's in printables. So it's done by Nerys, Nerys. He's got a lot of cool models up there, but I really like this one because I'm a flashlight connoisseur, if you ask people. And so basically it's got the description. He's got a little bit of a video here on how to build it. He's got some links to some parts, et cetera, et cetera. So that is the model that we're going to be working on this evening, one of them. And the other model we're going to be working on is this power bank right here. And this is by Shop Therapy. I've watched some of Shop Therapy's videos. He's got some really cool stuff out there. Hey, Tuxedo. I don't need an update right now, and I'm not going to restart another time. There we go. Just looking at my laptop. It's asking me if I want to update. Hey, Betty Boop is here. 3D Medic Vince is here. And Tuxedo is here. Hello, guys. And yeah, so here we go right there. This one's on Maker World. And this is a power bank, as I said, by Shop Therapy. Very simple. It's got one electronic component involved in it and a couple batteries and some prints. And this is the video I saw for it. But I made an error because I did watch the video fully through, but I totally forgot about one piece. And there's a certain piece in here where he modified, so he put a little bit of an additional piece right there with a screw hole. I totally and unapologetically forgot to do that in the pieces that I made. So I'm going to go through and I'm going to modify that, and it'll be quick, and it's actually quite a quick print. And so just to show you that piece, here it is in Fusion, the one that I did in Fusion. I kind of, well, if we go back and look at his, I'm not going to play the whole video because it's 30 minutes long, but basically in the video he had his, he had the batteries, which I've got. He did the tutorial on how he designed it, how he fit the batteries, et cetera, right down to the module for the USB ports, and all the way down to this, boom, and then he printed out the case. But the main difference is, there you go, so there's the finished case. Now the main difference in what he has done and what I am going to do, if I go to my Fusion 360 model, no, I won't go to the Fusion 360 model. First of all, I'll show you the main difference. Is I picked up the proper, I guess they're called modules. These are like charging, I don't even know what these things are called, to be honest with you. But they're the part that you put on, you solder the battery onto. It's got a USB-C and a USB-A, and this is what charges your battery. It's a two-way board. Charges your battery, and then you can plug your device into it to charge your device from the batteries. Okay, so I'm not into all the electronic stuff, so I don't know the name of this. I just ordered what he had suggested that be ordered from AliExpress. Let's see, David Waltons is here. Andy V is here. Somebody else is here because the dog's barking like mad. I wonder who is. Let me just check because Ethan's alone upstairs. It's almost like there's somebody came in or at the door. Let me just double check my camera. Let's just see who's here. Let's just see real quick. Boom, boom, boom. I'm all about safety. I don't think anybody's here. I think he just saw somebody out front. Okay. Anyways, the main difference, if I can pull this camera over, so the ones that he's got, I'll just show you the difference on the module here. Let's go to this camera and let's cut to the. Okay, so this is the actual charging module, or whatever you want to call this piece. Here it is. Come on, focus on it. Right there. There it is, right there. Okay, so you have a USB-A, USB-C. Okay. Now the ones I got, the ones that he got he showed did not have this digital display on it right here. And I wanted this digital display to show me the percentage of the battery it's charged. Okay, so how much power is left on it. So I picked these up. They were actually the same price, if not pennies difference. Very, very little difference in price. So I got that one, okay? And so let's go back to me. Hi, back to me. Somebody else has joined in too. Ranch Kid. I think I said hi to Ranch Kid. Another CG. And I think I've said hi to everybody. Oh, One Raz. William Nelson. I'm trying to say hi to everybody as you guys come on. So, and if I forgot you, don't take it personal. It's just that I'm into my spiel. Okay, so let's go back to the display. That's kind of funky right there. But let's go into Fusion, and I'll show you what I did. Okay, so in Fusion, am I on my display? I guess I am. Oh, hang on a minute. Let me just do something here. Let's go back to this and then back to, where are we? Fusion here. There we are. Okay, so this is, let me bring the other body in. Well, so this is the part that I have to modify, okay? So I modeled this up, no big deal, following his instructions, but I want to put another piece in here for screwing the board onto there so that I don't have to hot glue it so that it stays in place. The board probably has under voltage detection circuitry. Yeah, it probably does. So many people on live right now, yet I chose DeWitt to stick and watch. Oh, that's so nice. Thank you, another CG. Plus, you know, you have to show a little bit of mercy to me and us, I guess. What's going on? Where's my screen? There we are. Because Canada lost to the US for the gold medal round today, right? Apparently. I was at a birthday party for Ethan, so I didn't see it or hear, but I heard that it was a good game and that US won gold. Congratulations to the US men's hockey team. And Canada, you got silver. Hey, it's all good. So there we go. So you got to be nice to me. So there we go. Fully charging lithium-ion cells will destroy them. Okay, well, and that's probably another good reason to have. Are these lithium ion though? Let's see. Are these lithium ion? These are lithium. These are lithium. Yeah, lithium ion. But maybe there's a thing in there to protect it from charging fully. I don't know. But then another reason to have that display to see that it, you know, at 90%, boom, let it go, stop it. So yeah. Let's see. Oh, Chuck Hellebuck's son was the American goalie. Very cool. What else is going on? Yeah, congrats to the U.S. Olympic team for sure. I'm going to make this chat a little bigger. I can't read it too easy here. There we go. Ah, that's much better. Fully discharging them. You destroy. Oh, of course. Well, there's another question I'm going to show you guys and ask you a question about. I got something else on that. You might notice I have something else sitting on the bench here, but I'm hoping there's some experts on there in batteries that can maybe help me out with this. If I missed your question, just post again because I've got my chat a little bigger. I can only see like 10 comments at a time here. So, yeah. Oh, and John's here. Hello, hello. I'm not pronouncing some last names because I butcher them. So, okay. Plenty of battery experts here. Good, good. Don't know if that applies to lithium polymer cells. Anyways, we're going to go on. So what I did, boom, boom, we're going back here, back to the display, and we'll go back to this. So as I said, I've got to put a little shelf in here, so to help support the board that's going on there, and I get that from, if I go back to here, and if I go to the video right here, and if you look in his video, he mentions that towards the end that he did it off camera. I don't know if you guys can hear that, but they'll show the right there. He pointed that piece right there. He said off camera, he modified it a little bit. He was going to glue the board on with hot glue, but he figured that might not hold enough. So he modified that to put a screw hole in there to basically screw the board down. He hasn't given me any dimensions or anything, so I'm just going to dimension that up really quick here. And we'll do about a 2.8 millimeter hole so we can basically create threads with a 3 millimeter screw. So that's what we'll do off camera here, or on camera here. And we'll get that piece printing while we work on some other stuff. So I'm going to take this, I'm going to put that little modification in here, but first I need to figure out the sizing I need and all that. So yeah. Why am I not on? There we go. There we go. I'm back on screen. You always prefer a screw hole. Yeah, well, to glue for sure, because then it's easier to get off and on. So so this is the piece we're going to modify. So what I need to do is do a quick measurement here of how far I want that little ledge to come out. So let me grab my calipers So let me switch to the overhead camera view for you guys so you can see what's actually going on here. Is that the close-up camera view? Yeah, it is a close-up. Look at that. I can probably go a little bit closer too. There we go. So this is the sled that the board goes in here. Okay, so there's our USB-C and our USB-A. This slips in here just like that. So we have our USB-A and our USB-C. And then the board sort of sits on here. And his initial thought was to hot glue the board in place, but instead he made a little bit of a ledge here. So I'm just going to measure. Let me get my caliper activated here. There we go. Make sure I'm zeroed. So we're going to measure out from there to the end of the board, which is about 5.9. So we're going to come out around 8 millimeters. About 8 millimeters out is the length that we need it, and then we'll put a hole through it and we'll screw into the plastic. Instead of putting, I could put a heat inset in, but I don't think it's necessary. So we're going to call it 8 millimeters. 8.5 millimeters or something out, because we got lots of room on the sled here to play with. So let's go ahead and do that. 8 millimeters, we'll call it. Okay. Okay, 8 millimeters. So let's go back to the main screen, and then we're going to go back to our display and into Fusion. And really quickly, we'll just do this really fast. So we're going to create a sketch on this surface here. Let's bring it in. Okay, let's P for project. We're going to project this shape right here. Okay, that'll allow me to get a center line. That'll allow me to find the middle of this line, I hope. It should. Let me turn my origin on here. Where's my origin on this whole thing? Oh, it's way over there, my origin. I don't have an origin over here. That's fine. Okay, so I'm going to draw a line. I want it to be a construction line. We're going to find the middle of this right there. So we're going to draw down, just do a construction line. Boom. Okay, take that off. And then we're going to do a rectangle. So we'll make it, I said, we'll make it around. Let's see how wide I want to do that. I want to do that not too wide. I want to do that rectangle maybe 9 millimeters wide. Oh. Come on. Oh, let's do that again. 9 millimeters. I can't see chat right now, so if you're screaming at me, just be patient. 9, and I said, I'll go 8.5 millimeters. Oh, that's going to be the extrusion. So we actually want to make that rectangle right down to the bottom. Here, let's escape out of here. Let's do that again. Come up here. We're going to go right down to the bottom of that. And we're going to do, I said 9 millimeters wide. Okay. Then we will go ahead and, where's my center constraint? Why do I not have my center constraint turned on here? Midpoint. On that to make it on the midpoint. And then I want to go ahead and just create some angles here so that it doesn't interfere with the electronic portion of it. So we'll just come down something like that, down something like that. Okay, and let's go ahead and dimension that. So we'll go from here to here. We'll make that around 2.5. Whoops, fat fingers. And here to here, 2.5. That should give us plenty of room for the hole, and then we'll just get this dimensioned here. And there we go. So we're all dimensioned. Our sketch is locked, so we'll go finish sketch. And then we're going to go ahead and extrude this portion, and I said I'm going to go 8.5 millimeters out. Should be plenty, like that. So there's our little shelf. Now I just need the screw hole. So we are going to do a quick sketch on top of this. Come on. $10 says his Fusion is not up to date. Fusion updates every day. My Fusion is up to date, actually. I can actually do a new, I'll show you. My Fusion is up to date as of about 5 days ago. $10. You owe me $10. Super chat button's right there. There you go, another CG. You can just use add a hole feature. I guess I can. You mean like just basically come here and create a hole? Create, where's my hole feature? Create a hole, where is it? There's a hole feature, I know, but see, I'd have finished the other one by now. See, again, I am learning Fusion as I go. I've been using Fusion for 5 years and learning little bits as I go. I know there's a create a hole, there's add a hole, but oh, right there, create a hole, and I can do it. Yeah, see, to me, this is just a little bit too, I don't know, I don't have as much control as to where I put that hole. But I still need some reference. So I'm going to cancel that. I'm just going to go where I was going because I still need some reference points in order to add that hole, right? So it's just as easy for me to edit sketch. I'm just going to figure out how far I need that hole out from the front, or from that base where I was at. So let me just measure to the middle of that hole. Just give me a second here. So we are looking. I'm going to actually go from, I'm going to measure from the front of the piece to the middle of the hole. We are looking at about 33.7 millimeters. So I'm going to do on this sketch, I'm going to project this. Oh, actually, I'm going to project P for project. We're going to project this, and we're going to project this piece. Okay, and I want 33, so I'm going to just really quickly give myself a line to go by. Right there, we'll come right down here so I know the middle. Yes, this is going to be a different way than everybody would do it, I understand, but that's okay. So we're going to create a hole here. We'll call this 2.5 millimeters. That should be enough to grip the threads. 2.4 should be enough for me to be able to screw into the threads. And I said 33.7 millimeters, so we're going to dimension from the middle of the hole to here. 33.7. Okay, there we go. There's our hole. Finished sketch. And there's the hole we're going to screw into. Hey, Raj D, how are you, sir? Holes go quick and you know how to use them. Exactly. I need to, it's going to be an M3, another CG, so 2.3, 2.5, as long as I get enough in there to bite the threads. I might make that top little bit a little wider on that one. And I don't need to go too deep, so I can just go down. Probably need no more than, you know, minus 10 millimeters on that. Like I can just go right down, not even that, just enough to use an M3 by 6 or 5 or 4 screw. So let's just go down 7 millimeters, and then there's our hole. I don't want the piece to crack. That's the problem, right? So I'm just going to quickly go in and edit that first sketch. And I'm just going to make this gap over here. I'm going to make that 2 millimeters and make this one 2 millimeters. I could have mirrored this and it would have done it in one foul swoop. I get it, but then we'll just finish the sketch like that, and that looks a little better there to me. So that should be fine. 2 millimeters, 2.5 is a recommended setting for tapping. It's easy enough then. Okay, if that's a recommended setting, we'll go with that. So we'll just come here and we'll say, instead of 2.4, we'll go 2.5. There we go. So that should work right there nicely. So I'm going to give this just a little bit of a, little tiny bit of a fillet, 0.5 or so, actually 0.2, just so the screw has a little bit of, just to give the screw a little bit of a head start. So we'll just do that. Yeah, not much difference, no. As long as there's going to be 0.5 millimeter to bite there, so that should be fine for what we're doing here. So right there, that should be fine. It's going to print in this orientation like that. This should give me everything I need, and this should help do what I need to do. So I'm going to go ahead and save what I've been doing here. Say okay. So, and the way this is going to work, if I bring the other body in, okay, which is the entire thing, this is the way it's going to work. And if I go to my analysis and show you the analysis of it, so this basically, the battery is going to sit in this whole compartment here, and this sled, the sled for the electronics, will slide right in there and friction fit. And it will only go so far because this little ledge here is where the batteries are going to rest again. So this compartment from here down to here is the length of the batteries. So the batteries will sit right in there. Yeah. Normally you chamfer those, but a fillet will work. Yeah. I chamfered, well, I filleted here. I would normally chamfer the bottom. Actually, I think I did chamfer the bottom on here. Or did I fillet it? I filleted it. Fillet and chamfers are pretty close to doing the same thing, but I like using a chamfer on the bottom of a model so that I don't get that elephant's foot, et cetera, et cetera. So, okay, anyways, let's hide this body. Actually, you know what? I'm just going to go ahead and turn off analysis. That's fine. And I've saved it. I'm going to go ahead and export the whole thing. It's going to be exported as a step file, module V7. It's going to export to my download folder. We're going to minimize this. Minimize this. I'm going to print this on the, minimize this, kind of freaky windows. I'm going to print this on the bamboo. So we'll get rid of this first one we did. We'll get rid of this one we did. We'll bring that in. We'll bring that V7 in from the downloads. Right there. Let's bring it in. Okay. And then we're going to go ahead and split into bodies. Split to objects, I mean, sorry. We don't want that one. That's the one we want. We want that surface to be down. And I believe all of my printing parameters are in there, except I want that to be number 4 in red. We're going to slice it up. Section views are incredibly useful. Yes, I agree. So the slicing of that up, and then that is going to be a whole 28 minutes to print that. So let's go ahead and just send that to print and go. And then we can get that printing while we're working on the rest of the stuff. So, and it is on its way to print. There we go. Okay, let's minimize this. Let's get back to where we were in here, and let me go back to me. There we go. Really quick, a reload from disk on the part. Really? Okay. Avoids having to delete it and reopen it. But it was a different version. I think at version 7, and I think the last one I did exported as V6. Either way, it's just a tiny step, but I appreciate that. So what I did is I printed 3 different colors just to try my different printers. The bodies are fine. So this one was printed on the, excuse me, let me go to the other camera. This one was printed on the Elegoo Century Carbon. This is in the high temperature filament, Polymaker high temperature PLA, and this is the Power Tool Green, it's called. Okay, Power Tool Green. Okay, so I printed that, of course, with this, which is wrong. I got to toss these little pieces out and redo them because I'm going to be making a few of these power banks if they work out successfully. So you'll see the other addition I made in them, and here's the one that we're printing now. This was printed on the bamboo P1P. As I put a little window, and we're going to find out if it's in the right spot. I put a little window in so that when I put the module and slide the whole tray in, the idea is that that should, it's hard to hold, but anyways, that the percentage display here is going to show through this little window. Okay. That's the idea, because his, as I say, the one that the gentleman built on the video I watched didn't have this display, so he had no window at all, but I wanted the power display. And then the blue one, this is Polymaker Pet G, Polymaker Teal Pet G, and this was printed on the Flashford Adventure 5M. Now, I made a mistake. I should have moved it, but the seam, I don't like, I've got the seam right there. I should have really put the seam around back or on the other side, but I've got my seam running straight from where my window is, and so I'm probably not going to use this one, but I wanted to, basically I wanted to compare the 3 printers and see what sort of prints I'm getting, and they're all looking really good. I just didn't pay much attention to where I was putting the seam, so, but that's here nor there, as long as the power banks do their job, right? So there we go. It is quite a seam, yeah. Especially on the on the blue one. It's very noticeable. But yeah, but the beauty of it is these sleds, which are going to have the electronics in them. I won't slide it in that way. It's hard to get out. But the fit on these is perfect. You'll see. Oops. You'll see that the sleds slide in there just nicely friction fit for when it's all put together, and with the ability to come out. Now, that said, once I put the sled in its final position, it's not going to be easy to pull it out because its inset's a little bit back beyond this. So I've got to make sure before I put everything together that the wiring and electronics are working fine. Then I can assemble it, okay? And then if I ever need to change anything, I will likely have to crack or break this case open. But just similar to the Forever flashlight that we're going to do, that's the beauty of it, is if I have to replace the batteries or change everything, all I do is I just print a new piece. It's what, 25, 30, 40 cents in filament, if that, right, for these. So that's one of the beauties of 3D printing, is we can just reprint things that we have to as we need to. So there we go. Sell $10 a pop. Oh, I would, these things here, if you know how much it costs to buy these battery packs for charging your phones and stuff, $10 each is cheap. Because I have to, number one, I have to figure out the cost of these batteries I'm using. Okay, so these are the batteries these are the batteries we're using on this. These are Just Pow. These are on Amazon. 21700 3.7 lithium ion 5000 milliamp batteries. These are going to be in parallel. So we're going to have 10,000 milliamps, and then these batteries slide in. These batteries, they're in the plastic, mind you, right now. These things will slide in the case. If I take them out of the pack, let's just take the batteries out of the their shrink wrap packaging they come in right now, and I'll show you. But these batteries are meant to fit in there nice and snug, and yes, there is a vent hole on the bottom for some airflow. So batteries not included. Oh, I get it. Yeah. So let's just see. Let's pop these batteries out of here. Here we go. So these will go in. I'm going to hot glue them together, but these, you'll see that that's a snug fit. Okay, so that's a very snug fit. I was going to shrink wrap the batteries together, but I don't think I'm going to need to because they're going to fit nice and snug in there. And again, the wiring will run sort of up between the batteries, because we're going to hot glue the batteries together before we put them in. So that'll pop out like that. So there we go. And then we're going to solder them together, top and bottom, put them in parallel. So series would be like that, which would double my voltage. If I'm not mistaken, series doubles my voltage, parallel doubles my my amp hours. So, but that's how we're gonna handle them. I'm just speaking what I learned, if you want to call it that. Now, I want to see the tolerance in these other ones and see if it's about the same. Okay, that's a little little looser here. Okay, and the one that was done in the Elegoo, little looser tolerance. This is the tighter tolerance that was done on the bamboo, okay? And this was done on the Flash Forge, and it's about a little looser, so it's about midway between the bamboo and the Elegoo as far as the tolerance goes. So it's interesting how 3 different printers are giving me little bit different tolerances on the batteries going in. So there we go. Okay. But I got to sacrifice one of these in order to make sure my my gauge is going to line up with my windows. So all PETG, no. PETG, PLA, and PLA. These things should not get too hot, so I'm not overly worried about melting. So we'll see. Could be printer, could be filament, of course, absolutely. But it's very little difference. So since the LEDs are low voltage, you hook up the cells in parallel. Oh, this has nothing to do with LEDs. We're not hooking up LEDs to this one. This is the charger, not the light. So let's leave that sitting there for now, and we'll get back to that as soon as I get that part printed. Okay, so these are the items over here that we're going to be using to build the battery pack. Now, that's the battery pack. Now we get to the flashlight. Okay, we have all, well, actually, I'm going to sacrifice one of these because I do need to make sure that this window aligns, that the window in the case I made aligns with this. So let's go ahead and sacrifice, well, the blue one. Yeah, maybe the green one. Where did I put the green sled for this one? Oh, I think I threw the sled out, didn't I? Why would I do that? I need to test it. There it is. Okay, there's the green sled. This slides in just like this, so that our USB-C and our USB-A line up. You can brush them back out from the vent maybe. Push them back. Oh yeah, maybe, possibly. Oh, the other thing that's going to happen is this has a little thermistor on it we don't need, so we're going to be taking the thermistor off and we're just going to be connecting these two solder joints on there so we override the thermistor. So we don't need those. So actually, let me do that for this right now. Let me just snip them off. And we're going to solder these two together once we get to that point. That's for the thermistor. And so this one is going to sit in there just like this. I might actually have to glue that on just to do this little test. I want to basically do this and see if my windows align, and if they do, yeah, I don't know if I'll be able to push that out without damaging it or not. It has the bad seams. Yeah, this one's got not a bad seam. Actually, you know, that's a good point. Let's use the one with the bad seams. Good point there, Indie Nations. Good point. Good point. Let's use the blue one since it has the awful seam on it. Yeah. So let me grab where's my little glue gun here? Just going to plug in my little glue gun. Just going to plug this guy in. And this is going to be we're going to be doing this over a few live streams. We're not in a rush to get all this done. But there's a lot of thinking process. But once we do the first one, you know, the balance of them should be reasonably easy to do. So where's my power switch on this? Right here. Let's heat up the glue gun, and I'm just going to see if this thing lines up pretty good. Lines up the way it should. Okay, we're going to let this glue gun heat up. It should be pretty quick. It's a pretty big glue gun. Stick the batteries in with it so you have something to push on. Yeah, good point. Good point. Oh, and the sled was designed actually too, and it's really cool the way he designed this sled. And I basically followed along and did it in Fusion as well. But the sled is designed so that you put your board in here, okay, and then the batteries rest. So your batteries are never going to actually come too close to your electronic board, so you don't get any shorting from your batteries. That's why. Hence the little ledge on the sled on the bottom. Whoops, on the bottom there. So if we throw the batteries in here, let's pop them down all the way down. It's a little tight going in there, but they're in. Are they all the way in? There we go. And there we go. The batteries are all the way down in there. I'm going to have to definitely break this to get them out, because that is in there super tight, unless I can find something thin enough to push it out. Loop a ribbon over the battery when you push it in so you can pull it out from the other side. Now he says so. Now you say so. That's okay. And then that's going to go in, and that's going to prevent the batteries from riding right up. But that's going to hit the batteries, and that'll put us right at the proper depth for the batteries. Why does that one battery seem to be sticking up a bit more? Yeah, I may have to loosen the tolerance in here a little bit. But we'll cross that bridge when we come to it. So our glue gun should be hot now, so I'm just going to quickly put this piece in. And I'm just going to glue, just going to glue, put a little bit. Are we hot yet? Oh, there we are. Oh, gosh, okay. There we are. It just wasn't pushed through. We'll put a little bit there. Come on, you're really stringy. And we'll put a little bit right there. Okay, stringy glue. Okay, and we'll put this aside. Okay, there we go. Let that dry a little bit. That's very stringy glue. Holy crap. Oh, it didn't go in there straight. Why? Why didn't you go in straight? It's okay. It's not what I need to know. And I'm just going to get all some of these strings off. Okay. Dry my glue. Oh, because it's stringy? Yeah. Okay, so that's fine. We got that in. I might have to change that one location. But now, so if I push this in, ideally, it's not quite on. There we go. So that's how that sort of sits in, just like that. Okay. And then my window is off by just a little bit. I don't know if you can see that there, or maybe on the other camera it's better, but my window is off just by, oh, I don't know, probably 5 millimeters, 3 to 5 millimeters. My window's off. It should be basically out towards the front a bit more. But you could still see it. That's the thing, is you can still see it, but it could be better, right? So there we go. But that's what the thing, that's when it's put together, that's sort of what it's going to all look like, just like that. Yeah. So, okay, let's try and get this apart. Now, let me turn the glue gun off for the time being. Okay. Oh, I got all sorts of funky glue hair here. There we go. Comes off the wood easy, thank goodness. Depth tool on the calipers may be thin enough. Yeah. Anyways, let's see. Depth tool. No, it's very thin in the back here. I know what you mean, but yeah, it's very thin. It doesn't matter. I'm not overly worried about wrecking this one, because this did have the bad. Let's see. That's not going to come out easy that way. Let's go ahead and grab some. I think I know what might work. Possibly this little screwdriver. No, it's still too thick to go through there. Those are just really slim little things underneath. Now, can I push this up this way? There we go. Little gap there. There we go. That lets the tray come out no problem, just like that. Okay, so there's our tray. So what I know now is I need to open that hole up just a little bit more, maybe to there. I got to move that. I got to shift that hole down just that little amount. Probably that's like 2 millimeters, so I can do that easily in Fusion. So I have that hole open. That's fine. Now to get the batteries out of here, that's another trick. What do I have that's thin enough to go down there? Let's see. Although I don't think it's going to be very successful at pushing the batteries out, because they're wedged in there pretty tight. I think I am just going to, yeah, I think I'm just going to sacrifice this case. And I think what I'm going to do is increase the tolerance. Actually, the green ones seem to be the best tolerance. So let's just get these out of this. Hang on, I'm going to make a bang here, just so you know. It's going to make a loud noise. Oh yeah, they're coming out. They're coming out. Oh yeah. There we go. We've made it that far, so hang on. There we go. That worked. So I didn't have to kill the case, although the window's not in the right spot anyways. But these ones will go in this one. Oh, a whole lot easier. Look at that. They just fell right in, and they just come right out. So not a big deal. Perfect. Okay. My voice on the speaker, that freaked me out. The green is the good fit. So I don't know whether it's the printer tolerance or whether it's the filament tolerance. This is the Power Tool Green High Temperature PLA from Polymaker, but I love the surface finish on this one too. It's a matte, very nice matte surface finish. If you look, ooh-be-doo-be-doo-be-doo-be-doo, if you look here. Love the surface finish on this thing. Like, look at that. You can just see it. It's a nice matte, there's the seam there. There's a nice matte surface finish. So, yeah. Hey, Brent Ferguson! Butter knife. Butter knife would probably have worked too. Okay, so I'm printing the red for some reason. Maybe I'll just print this in the green. Let me switch that over to that printer, and I'll print a green one instead of the red one. See, we have to do a lot of sacrificial printing for this too, right? Like this was my initial test case for the fit, for the battery fit and everything, right? So it's the initial prints. There was these two prints, then there was the initial print here, right here for the to fit the USB board. So in other words, this was printed to make sure that these pieces were fitting properly. Okay, on the front here. And then we print the sled to make sure that everything's fitting there, and we print this to make sure that we have good fit for the battery and that it's a good fit for the sled sliding into that piece like so. Okay, so a lot of sacrificial printing going on when you're doing stuff like this, which is fine. It's to be expected, but obviously green wins. I love this color. So let's go ahead. I know I'm printing the one actually, I'm going to let the one on the bamboo continue printing. I'm going to let that one continue printing, and I'm going to test the screw hole first before I print it in the green, since it's printing anyways. That way, if I have to make any adjustments, I just make it on that one. Okay, so the glue gun's pretty much cooled off. Let's just get this out of the way for now. We'll come back to that. Okay. Tonight's going to be more about the process of test fitting, of getting the prints right, etc. For the battery charger. Okay, we're gonna have to work on that one obviously a little bit more. I do, in fact, although I do have all the pieces in place now, we can move on a little bit to the flashlight. These kind of go hand in hand in a sense because they're both involving charging and batteries and so forth. So yeah, I know that's really good, Tim. Anyway, so let's go ahead and see what's going to happen with these. So we have the top, we have the bottom, okay, and then we have a couple other pieces. So we have the LED holder here. We have a spacer here, which I believe is going in the bottom, and it's going to basically cause the battery to snug up. I have not done any of the, there's not any good schematic of the wiring for this, so this is going to be some guesswork based on what I watched on Chris's stream. So, still got to go back to Fusion to adjust the large window. Exactly, I do have to do that. We'll go back into Fusion and do that once that other piece prints. And if I find that other test piece is printing good, then we'll go back in and we'll fix the window in Fusion, and then we'll also print the other case for that. But yeah, so yeah, this goes in here. This was a sacrifice, but it gives you a good indication of what the empty shell looks like. So that is meant to go in by about 1 millimeter in. And that's basically what the empty case looks like without the batteries. But this one here is a sacrificial lamb. It goes into the recycling. The blue one's got my measurement for how much I need to move that window. We'll hang on to him. And this one's got my hot glue. The hot glue actually did a decent job of holding this in. But the thing is, you got to make sure, and the reason for going with the screw is because you're going to be plugging a USB cable in and out of this thing. And the hot glue may eventually loosen up. So right now I can actually take that off just that easy with the glue, and the glue just came off super easy. So not really good for holding up under constant push and pull conditions, I would think. I think that the smart thing was to go ahead and put that screw in there. So anyways, back over to the flashlight for now. The pieces we were waiting for last time were the heat sinks, which we've got, and these are 40 by 40 by 11 millimeter heat sinks. So that takes 2 heat sinks per light, and these are all from AliExpress. These are aluminum heat sinks, and I believe it was 7 pack of heat sinks. These were, I don't know what, $5 something. Anyways, cheap AliExpress stuff. So what happens with these is we put, the light goes on here. Now, I haven't considered the wiring on this because the wiring is going to be happening on the front of these things. Hey, Big Bad Joe. Hello, hello. Do you have a link for the laser cutter you got? How do you like it now that you've had it a while? The laser cutter. The laser cutter. Are you talking the? Are you talking the this laser? I'm not sure which one you're talking there, Brent. Just want to make sure we're talking the same. I just want to make sure we're talking apples and oranges. And then so the LEDs are going to go in here, like so. It just kind of fits in that little window. Okay, and then the heat sinks will go just like that. So we have the heat sinks with the LEDs on them. I haven't really thought, so we're going to obviously have the wiring coming up probably through the middle of the LED or the heat sinks. These are adhesive heat sinks, so I'll probably, I don't know, I'm not sure how this is all, oh no, but then again what happens is then that gets screwed onto that, just like so. Okay, and that'll hold everything nice and tightly in place. Yes, big ass heat sinks. They are big. I'm just looking, I'm just waiting to see what Brent's saying there. So that's going to be put together like that, and obviously the wiring is going to have to come down through the inside of these holes here and down. What I want to do with these before I do any assembly is because the wiring on this one is just something that I simply took notes on watching Chris's, and then he kind of dictated how the wiring is going to work for me. So I want to make sure it's going to work. So the wiring I have for this is the notes I took right there. Right there, I wrote some notes down. Forever flashlight wiring sequence. Heatsink should be fixed using the heatsink tape. Yeah, they have tape on them. So I'll probably use that on them and peel the tape off and fix it on like that. And then the rest of it will hold it in place. Because he also said the heat sinks he used I don't think had adhesive, and he just used them with the pressure from screwing this piece back onto it that held everything in place. So the laser cutter you broke the tube on and had to rework. Oh, you mean the CO2 laser? That's a whole other story that I'm not going to get into tonight, but I will get into it another time. I may even PM you about what happened to that CO2 laser. That's a whole other story, but we'll check. Never did get it to work too well. I can summarize that. No, I wouldn't buy one, and I never got it to work too well. So. And yes, way too small. Way too small. Yeah, way too small. Lesson learned and blah, blah, blah. So we'll move on. Okay, so for the flashlight, I was waiting for the heat sinks. And I was waiting for these parts, which are called... these are fast charging test board. Adjustable PD trigger... Anyways, these are the boards I was waiting for right here. They look like this. I don't know, there's no information as far as what the dip switches are for, but when I watched Chris make his lights, he didn't touch the dip switches, so I'm not going to worry about touching the dip switches. So we were waiting for that, which I believe was called the BMS. No, this isn't the BMS, this is the PD trigger. This is the PD trigger, what this is called. Yeah, PD fast charging test board. So a PD trigger. Again, I don't have any clue what the dip switches are for. I guess I could look it up, but I'm just going on the fact that he didn't use the dip switches. He left them all in the same position, so that's what we're going to do. So I got a bunch of these in from AliExpress again. This is a pack of 20 pieces, because that's what it came in, was 20. I've got more than I'll ever need, but hey, we have that. We have the heat sinks. We have the LED pucks, or whatever you want to call these little plates. We talked about them last week. I forget what they're called again. I call them little LED pucks. So voltage selection for charging. Mine is collecting dust. Yeah, good to know. And I've learned a new respect for women now. Really? From what anyways, there we go. Okay, so we got that. Then these are the these little guys here. This is the this is an LED driver. So basically, this is a driver with a potentiometer on it that we can adjust the voltage going to the LED, the final voltage going to the LEDs. Power delivery trigger. There we go. Power delivery trigger. See, I learn something new every day. So we're going to be using 3 of those per light because we're having 3 LEDs on the light. And then this little guy here is the a BMS, which is, again, you guys know better what a BMS does than I do. This is something about a battery management system or something like that, something for controlling the charging to the battery. Okay, so I just know that I've seen how it works, seen how to hook it up, etc., etc. So we have a P plus, P minus, and a B plus, B minus. So we have to figure out how to use that. When using a PD rated can deliver your voltage at a specific voltage. That's probably what the dip switches are then for, is to change the voltage that the PD is delivering. But we're only going, I believe it's 3.7 volts in based on the batteries. So I believe the batteries are 3.7 volts. We'll just double check. I'm pretty sure that's what they are. Yeah, 3.2 volts batteries. And then on top of those things, we have the switch. That's our 3-way switch. Off, up, down, because we're going to have up for the front top 2 LEDs, and we're going to have down for the side LED. And we're just going to wire that up accordingly. So, and I believe that's all the electronics involved in this. Let me just double check. So the instructions that I got, let's see. Hey, Bellador. Oh, don't forget, guys, before I forget, and if you're just popping here, don't forget to go up and enter. It's pinned at the top of the chat. Enter to win some Polymaker, and it's also pinned in. It's also in the description of the video. The link to the Google sheet. Enter only once because I will be checking the spreadsheet, and you're going to have a few weeks of grace. But anybody that enters more than once after your few weeks of grace, depending on the mood I'm in that night, will be ineligible for the draw. But if I'm in a good mood, I'll just delete your double entry, and you'll be eligible for the draw. But we'll see. Aha! Okay. Lots of blue names in here. A lot of blue names, yes. Okay, so the instructions I got. Okay, use thicker wire from main power to supply to BMS. Say, okay, like a 20 gauge wire. Fair enough. Meter the battery for plus and minus connections to keep it consistent, so I know where the battery plus and minus is. Then I go battery to the BMS in, okay, which is the square pads on the BMS is the battery to the BMS in. Okay, we have a B plus and a B minus for the BMS board. And then with 20 gauge wire, battery BMS out, which is the oval pads, the BMS out goes to the PD trigger, okay? And then the PD trigger to the switch, center 2 pins to the switch, but I do not see an out on the PD trigger. That's the thing, unless I just have two going into this. So we'll see. We'll figure that out in a minute, though. Then PD trigger to the switch, okay, the center 2 pins of the switch with 22 or 24 gauge wire. And then the switch to the LED drivers, okay, into the LED drivers, and then the LED drivers out to the emitters. That's what I got. The out is those green terminals. Now, what's the in then on these? What would be the in? That's where I think that's where I'm a little confused. This reminds me that the 100 watts cob light flashlight video I saw a couple years back. Oh, cool. Seems a few of you are the black sheep. I don't know what the difference in color makes. I really don't know what that means. You guys have blue badges with you too. Well, the USB-C, and see, this says battery to BMS. Okay, BMS out to the PD trigger. This is the PD trigger, and then PD trigger to switch. So I might be misunderstanding some of this. That's why I want to wire this up and try it before I actually insert anything into the actual light. Green means member, blue means moderator. Oh, is that what it is? And what's the gray mean? Oh, cool, you'll be able to charge it. That's an excellent idea. So all I know is this guy here, this PD trigger goes in. Here, let's switch this. It's a learning experience as I go to. So the PD trigger is going in here something like this. If I'm not mistaken, if I got this right, or do I have it upside down? I've got to watch his video again too. But this is going in like this, so that's the charging port for the light. Right here is where you plug it in to charge it, okay? And the switch itself goes in here. Okay, so we have the PD trigger up here with the USB-C. We have the switch here. Okay, that's this side, and on the other side, whoops, or is the PD trigger on the other side? Let me just see. Maybe the PD trigger goes on the other side. No, I don't think so. Oh, that's the hole for the wiring, because this other side here is where the side LED is going to go, and I think that's the hole for the wiring to go in there. So the wiring diagram is on printables now. Ah, gray is a non-member. Oh, I get it. Okay, he was not a member of the YouTube group. Okay. Blue is mod. Oh, okay, I get it. Okay. It's just colors to me. Let me check the printables and see if he did have a wiring diagram in here now. Just going to double check that to make sure. Okay, let's see. Because he didn't have a wiring diagram initially. M3 screws. Don't see a wiring diagram yet. But that's okay. I can crude temp video instructions. No, I don't see a wiring diagram on his YouTube yet, or on the printables link yet. So we'll have to get back to that. There we go. There we go. You want to be orange? Orange? Crazy, man. Crazy. So with that said, with that said, there's a lot of soldering to be done here, a lot of wiring, but I do want to figure out BMS out from the oval pads of the BMS. Let's go this route. So the oval pads of the BMS are these two right here. So it says it goes out from that into the PD trigger. But then we got to go out from the PD trigger to the switch. Unless I mixed it up and it goes BMS out to the switch. But then the PD trigger's also got to go... No, because the PD trigger, this is what's going to charge the battery. This is where you plug it into charge. I'm so confused. Okay. But let's just do some things we know what to do here. So we're going to grab the battery. Let's check the voltage. I'm pretty sure we'll make sure that we'll figure out which is positive, which is negative end. I'm going to guess this is the positive on the top and this is the negative on the bottom based on the labeling, but you can never be too sure. So if we look at the meter here, I'll put that so it's visible that way. If I go boom and boom, helps if I turn the meter on. There we go. So we go boom and boom. We have 3.32 volts, which is perfect because it's a 3.2 volt battery. Is that upside down? No. Everything's kind of mirrored on that camera. Okay, whereas if I go the other way, let's just see what the other way does me. We have negative 3.32 volts. So obviously then that means that the top one, I was correct, where the label is facing top is, so here we have the label on the top, right there with the red and positive. We have the red going to the top. black going to the bottom, and that is giving us 3.32 volts. So we know that this is the positive terminal here. That is one big cell. And so, okay, so we know that the positive is on the top, negative on the bottom. Now, is it consistent? Let's just grab one of the other ones and double check on one of the other cells and make sure it's actually consistent, and if that's the way they've done it on purpose. So we red on the top, black on the bottom, 3.31 volts, and there's supposed to be a 3.2 volt battery. We're perfect. Yeah, okay, so we know that the positive is the one on the top. Okay, let's shut the meter off so we know. Okay, so we know those are consistent. So now this battery slides into here. It fits nicely on the bottom. It doesn't go up too far, so we have a lot of room inside for the electronics on the top of the battery. I need to get some nuts that are going to fit on that battery. I should have got some wing nuts for it. And then the bottom of it goes here, which is going to, the wire is going to run up. There's a little groove up here to the side to run the wires from the batteries. Whoops. He's got a little cutout on here so we can run some wiring down there. But I definitely need to find some nuts that are going to fit on there, and this should fit in there. Oh, then there's the battery spacer. I believe this was a spacer to go on the bottom. And then this went in like this, which held the battery very, pretty much holds the battery from wobbling around too much. But also, this might be the spacer. I think I needed to put a spacer on the top of this battery as well. That would run down inside like that. So the battery sits in there, and this spacer sits in here, and this, there, that tightens the battery right up. So that's what those spacers are there for. So we have some spacers to keep that battery in place, not wobbling at all. So, yes, I did check it out. Why not make a spacer out of TPU? They are spacers out of TPU. So this bottom, this is TPU, this bottom part, that's TPU, okay? This top part where the LEDs go, this is all TPU, okay? Beautiful, beautiful prints for TPU, aren't they? Look at that. And then this spacer is TPU. And then the spacer that went in before the battery is also TPU. That's a TPU spacer as well. Yeah. Yeah. Okay, so let me just check and see if I have, let me get some wire. Where are we at time-wise? 6 o'clock, we're an hour in. I'm kind of working on two different things here at once. Our little test print over there is finished. But I just need to organize some things here a little bit. These are 3.2 volt LED plates, so that's fine. We're going to wire those things up in parallel or whatever. So negative to positive, positive to negative. Although, no, I think I only need to run one driver to the two of these, if I'm not mistaken, because I can just solder the positive to negative, negative to positive, and then I can just have the wire out, and I can have the one driver running these two. So I can have these going in parallel. That should be fine. I was going to go get, see if I could find some screws to put, some nuts to put on those. And I don't know what size these are, whether these are metric. I'm going to assume they're metric. They look like they might be M5s or M6s. Let's go see if I can find something like that. There we go. Positive, positive, negative to negative is parallel, but I want these to be in series, I guess, in order to work proper. I'm pretty sure. It's in the files section. It's in the file. Oh, is it in the file section? Was there a file section there? Let me look. Did I miss it? Download, like, share, files. Oh. Let's see. Component schematics. Oh, okay. I missed that. Oh, there we are. Okay. Remind me later. Oh, okay. Okay, so thank you for pointing that out. Who pointed? Raj, thank you. I totally missed that. Here's what Raj pointed out to me. Look, there's the schematics right there. Okay, so we have that's our BMS right there. Okay, input of mine look a little different, but it's a BMS, okay. So we're going the battery to the BMS. Okay, P minus output, input, output, input, output. Okay, so we're going from the battery, then we're going out from those. Okay, this is the adjustable constant current LED driver, fair enough. Okay, but that doesn't, nothing in there is showing me the PD trigger. Where's the PD trigger? Hey, Sergio. I don't see a PD trigger on this, though. Huh. I don't think these are his. I think he grabbed these. Let me just see if there's anything different. B of M. Okay, the B of M is there. Okay, here's the B of M. Okay, like that. Those are just diagrams from there. So that is the, that's the battery. BMS board. Switch. There's the PD, fast charging. There's the heat sink, there's the wire, there's the JST plugs. But yeah, that doesn't tell me much about how the PD fast charging, where in the schematic that goes. Okay, we'll figure it out eventually. We'll figure it out eventually, no worries. Okay, let's get back. We'll figure that out. There we are. Okay. What's the equivalent resistance of these big boys? I have no idea. How would I figure that out? I have no idea how to get the resistance on that. All I know is what they say on them, that they are 3.2 volt, lithium phosphate, 20 amp capacity. 20 amp capacity. How much does it weigh when it's assembled? It's pretty heavy. It's going to be pretty heavy. Let me find some nuts that can go on the end of these batteries. Let's see. Where are all my nuts? I'm pretty sure they're going to be M6s. Pretty sure. Let's just see. What do I have here? Oh. Well, this isn't a nut, but this will tell me if it's the right size. Yeah, whatever this is, that's a hammer nut, but that's an M6, I believe. Or no, that's an M5. No, that's an M6 hammer nut. Okay, so I need some M6 nuts, which actually a hammer nut. I wonder if a hammer nut would work on this, because all it really has to do is tighten down the wiring. A hammer nut might just work on that. Like, look, why not? Save me buying some different stuff if I just use a hammer nut to tighten the wire down, right? Because that tightens down nicely on that. So yeah, if I don't have any, and it's almost like a wing nut, right? And I can just snug it down. Yeah, I might just use a hammer nut. Why not? Why not? So one on that end, and another on that end. Look at that. Just compromise. Use what you have. Use what your mama gave you. There we go. M6. Blue Loctite. You guys are funny. Okay, so let's get some wire. Let me go grab some wire. Let's see. Still got to talk to you guys about my other battery issue yet. I'm gonna go grab some wire from my wire bin. I'm just over at my wire bin. Okay, I think this one is what I need. Oh yeah, this has a lot of wire in it. Here, hang on. There's my wires. Silicone wire. Okay, excuse me. This is probably way too big. This is 12 gauge. Yeah, I don't need 12 gauge. I don't need that for a shotgun. What's this one here? This is 20 gauge. Yeah, that'll probably work. 20 gauge. What did he recommend? 20 gauge for the battery. Yeah. So that's a good 20 gauge wire right here. And then we've got, let's see, gosh, I got way too much stuff in here. I needed some JST. Those are all too thin. I got another bin of wire over there too. So this one looks like it'll probably be a good one for, this is probably about 22 gauge. Let's just see. Yeah, that's going to be 22 gauge right here. So that'll probably work for the other ones. It's not silicone though, but I'm not sure if that's going to make a huge difference. What are the LEDs rated for? Any less than 18 or 16? You think? Well, I've got this stuff. Keep in mind, the LEDs, I need to use a really thin wire on it because it's just, they're basically sitting in there flat. What do I have here? I'm just trying to find, I got all kinds of different kinds of wire in here. So this stuff here, this is all good silicone wire, and this is, just doesn't tell me what it is. But to me that looks like an 18 gauge. No. 30, 24, I don't know. I need a wire gauge tester, measurer. I've got another box of wire here which says it is, it doesn't tell me what it is. Oh great. But that's probably going to be fine enough for the LEDs, because that's probably more like a 22 or 24. That's probably a 24. And I can, yeah, use as big as it'll fit for sure, but there's not a whole lot of room to go down the side of that battery. What do I have here? The biggest wire I have is this 12 gauge, which is right here, which might fit down the side of that. This is 12 gauge silicone, so let's just see if that would fit. Okay, let's grab some of that. This is also, oh no, this is 12 gauge. Oh, definitely not. This might be, let's see, that's 12. This probably 16 or something. But this stuff should be plenty. Let's move this off to the side. 12 gauge is good. Yeah, but it's good, but will it fit down the side there? So let's just look at this. So if I put this in, and if I slide this, we can separate this. Will this fit in here with the battery? Let's just see if this was made to fit this size in. Very snug, but it might work. Mind you, I only got to run one battery from the bottom of the battery to the top. So, okay, 12 gauge is plenty. Yeah, it should be plenty. Okay, so let's go ahead. So we have the bottom. Battery is going to run there. We're going to run one wire up from the bottom, which is going to be the negative, and we're going to run the positive battery up from the top. I believe there's only one bottom battery, one bottom wire we need, which is our negative wire. Yeah. See, Tuxedo, it's like we're thinking alike. So if I take this, if I measure, oh, let's get to the bigger. Where did this go? There it is. I'm gonna find that. Let me bring me back. There we go. And I think I want this one. There we go. So if I measure, I'm just gonna overkill. We're just gonna cut this off here. Okay, I only need the black to go from the bottom. Okay, so let's go ahead and grab my, let's do this right if we're going to do it right. We're going to be jumping all over the place, by the way, just so you know. Where's my connectors? Terminals. I'm looking for my terminals. This will probably work. Need a terminal, and I can use this one. Oh, a little too small. How about this one? Come on. A little too small. Could have used a few pounds. This one? Too small. Where are my larger openings? I don't want the yellow one. It's too big. Oh, maybe I do need the yellow one. Oil catch can. That's too small. Man. Too small. These are big terminals on these batteries. Come on, let's just... maybe this red one. This should work. That's even too small. Wow, these are huge. Okay, that's what she said. Huh. That one. I think this one will work. This yellow one. Yeah, that's a perfect fit right there. But I'll just have to bend it up because it's going to need to go... Well, we'll see. I don't know if that's going to work, or I'll just wrap the wire. I don't know, we'll see. I'd rather use a terminal if I could, if I can. So if we put this one on, and we secure this with this, like so, and then we just gotta bend that terminal up like that, but I don't think that will allow the bottom. Let's see. Oh yeah, that'll let it close. Okay. It should be okay. With this, no, that's not going to quite cut it. It's hitting it. Yeah, no. Yeah. If you solder it, you can shorten it, yeah. Okay, let's pop this off. A lot of ideas floating around out there. Yeah, I can cut the plastic off. I can take, whoever said that, I can take the plastic off to about here and that'll be fine. Right about there. And I'm not worried about shorting it, so yeah, if I took all the plastic right off, it would be fine because there's nothing up there going to short it because it's all just negative. There's no other pieces of the battery up there. So yeah, if I cut the plastic right off, like so. Okay. Let's get my wire crimpers, my wire strippers. There's my 12 gauge. Yes, no, I'd want to screw onto these battery terminals. Screw onto these. Let's find my, see if I can get that to come off. I'll get that plastic off. There we go. Okay, got the plastic off. We can go ahead and, where's my crimper? That one or this one? This one. My crimper. Okay, so I can come in here. Come on, open up. And I can crimp. Actually, take the wire out. Let's get this in there like that. Let's put the wire in. Come on. I'm in the wrong one. That's why I want to be in this one. There we go. Let's put the wire in. And crimp it. Oh, good thing I didn't, yeah. Yeah, that's, again, the wrong one. Come on. You want to crimp. Crimp, crimp, crimp. The first crimp always fails. It sure does, doesn't it? So I want to be on the red one then, I guess. Let's be on this one. Come on. The first crimp is the deepest. That's not even the right spot. That one. This is showing my inexperience with this kind of electronics. I'm not used to these big wires. Ah! Arr! Oh, I have more of this terminal for sure, yeah, but it should work. Hang on. Let me do this. No, let's start over. Okay, let's start over. I have lots of those. I have lots of these. Let's get the plastic off. Well, the plastic's going to help, right? But no. Actually, let's get the plastic off first. No, I don't know what I'm doing. For anybody out there saying he doesn't know what he's doing. No, I don't know what I'm doing. This is new territory for me. Let's get the plastic off. Come on. Come on. Here. There we go. So I should have done this in the first one here, would be my guess. Let's try that. Let's not try that. This is just a comedy of errors. If you were an electrician, yeah, crimp it with the plastic. No, I want to cut the plastic short. Seriously? Oh, there. This is going to work. This is going to work. I guarantee it. Put you in there. Oh, maybe. Come on. Come on. Oh, you son of a Felbin. Worked, but can I get it out of here? Oh, man. Okay. That would have worked too. That was looking good. Okay, who said crimp it with the plastic on? Okay, we'll crimp it with the plastic like you suggest. With the yellow part, so we're going to go yellow in the yellow. I just think this is too big for this wire. Okay, there, yeah, see, it's too big for that wire. This needs a heavier gauge wire for these particular. Let's try it in the next slot here. Or I've got to double the wire up. No. Okay. Let's double the wire. I think it's the right crimper for that. Diagram showing the DC 2.5 to 6 volt input should be the USB-C plug. Yeah, but where's the output then? Or the other one, but yeah, I don't know. Anyways, we'll cross that bridge when we get to it. Let's double the wire thickness and crimp it. I would certainly think this is the proper crimping tool for these. Well, maybe it's not the right crimping tool for these. You know, maybe I'm just an idiot. Yeah, maybe it's not the right crimp. No, it can't be the right crimping tool. What else do I have for crimping tools? Let me see. Let me see what else I got for crimping tool. A comedy of errors. That's the only crimping tool I have, other than these other for the JST cables and stuff, which these definitely wouldn't be the right tools for that. 22 to 18. No, this would not be the right tool to use for these. Or would it? Or would it? I don't know. I don't know. I'm kind of at a loss. I should have stayed in bed this morning, right? Right. No, that's not the right tool for that. There's a right tool for the right job, and then there's the wrong tool for the wrong job. No, that's the only one I've got. Let me try something else here. Those crimp dies are cheap, yeah. Okay, this red one I can get to work, actually. If I can get this to crimp in this red one, this will work just fine. I just think that the wire I'm using is just too thin for these big yellow ones. These big yellow crimps I've been trying to use are crazily big. So if I just go ahead and use this red one instead, and that wire fits in there just nicely. Now if I use the red tip on this one for the red crimp, like that, now that is a good crimp. That's a good crimp. And I can get this just over that terminal, just like that. Okay, and then I can screw on the hammer nut and tighten that on just like that. That works. Am I sure that wire is 12? Well, I don't know. But if I bend that down and come down to the sides, is this going to actually go in? Let's just see. See if this is even going to go in. We got to put this first O-ring in. Okay, that first O-ring, run the wire down here through that hole. Get in through the hole. Okay, maybe we're going to do this. Put the ring through here, like this. See if I can get this to run down through the hole. I think I'm making things a little more difficult than they have to be, but that's just the way I operate. So, and then that is going to slide down and in. Oh, so I got the battery going the wrong way. Negative on the bottom, like so. And can I grab that wire and pull it through? I think this is going to work. If I get this through as much as I can, like that. If I grab this, where's my needle nose? Here we go. Grab the wire. Pull the wire through. Come on, slide down. Oh man, no. No, that's not going to work. Add some WD-40. There we go. Okay, let's back this up a tad. Okay. I'm going to get that wire. Oh, it's because it's going to go around the other side of the ring. I don't want that wire coming through that ring. I want that wire going on the other side of that ring, but yet, ay, ay, ay. Let's try this. Let's put you through. Put you through there. Let's put the ring here. Go through like that. The wire should be on the outside of the ring. It is. Let me grab it. Here we go. Nope. Everything's going all to hell here. Well, we're in the right spot now. But I'm afraid this is not as easy as I thought it was going to be. Do I have dielectric grease? No, I don't. I don't. I'll have to go back and watch his stream and exactly how he accomplished this, because I don't think it's supposed to be this difficult. And maybe this gauge wire is too thick. Let's see if I can pull that through now. There we go. Hang on. Did we get it? We got it. We got it. Now I just have to get this hooked into the bottom of this. I think I got it. Oh no, that's okay, Jerry. I've wasted 3/4 of my stream already, so. But I have a feeling that I just got it. I'll have to, in between now and next week, I'll have to figure out the wiring for that PD switch, for sure. So let me see if I can get this to go on there. There we go. And then we can put this down. Actually, if I screw that in this way. Whoops. Whoops. Slippery buggers. Screw that in this way. There we go. We got it. We got that to go. And then we got the wiring coming up here, which is good. And then I should be able to put this. We got that little cutout for the wire there. I'm going to make that little cutout a little bit bigger. There we go. Because I'm using, I think, a thicker gauge wire than he had intentioned. So that can go on there. And this can screw in the end. And there, that worked. And the battery is in there solid, and we have our negative wire coming out. Although, being the idiot that I am, I should have attached the positive wire while I had the battery out the other end. But I'll have to go through this whole process again. Because the positive wire is way down there. My fingers will not reach down that far. I should have put the positive wire on before I did all this crap. But hey, at least I know what I'm doing. I kind of know what I'm doing now. I want to smack myself over the head with this thing. Okay, but at least I know that I can use these red terminals. We'll take two of these more, we'll take two more of those out. I can use those red terminals to hook up to the other end of the battery. That was a dry run. Crap. Okay. Let's go ahead and grab this piece off the printer that I printed. Let's just back up from this for a minute. We're not gonna get a flashlight built tonight, just so you know. We're gonna learn the lessons. I'm gonna talk to Chris this week about how this PD trigger is supposed to. I'm gonna talk to him more about the wiring. Anyways, but these are the challenges we face, which makes the first one always the most difficult one, right? Once we learn from our challenges on these, I intend to make probably 4 or 5 of these. Once we learn from the challenges on these, we will, the next ones, as we know, will always go easier. So definitely go easier. Hey, Pirate 30. Okay, so you guys, I'm going to give you about another 5-minute head start, or 5-minute warning. We'll do the Polymaker draw in about 5 minutes. So go ahead and enter. There's a link pinned at the top of the chat or in the description where you can go and fill out the Google form and enter to win Polymaker. Only enter once though, please. Please. Just enter once. But in the meantime, one for each car. Nice spaceship door. You guys are, yeah. I'm having fun, and it's a learning experience. So we got this piece printed, this one here. So remember I added that little add-on piece for the M3 screw. So we got that printed, no problem. I'm going to test and see. Let me grab an M3 screw. I think an 8mm would probably be plenty. Probably even smaller than that. An M3/6 is probably plenty of size. Do I have a button head? I do. So we'll grab an M3/6 button head screw here. And let me get you a little closer to my action. Oh, that's a little farther away from my action. There we go. Let me bring you in a little tighter. There we go. Okay, so we're going to grab that M3 screw. We're going to grab a hex driver. And let's just see if this is going to thread in here okay without cracking. Oh yeah, that's going to thread fine without cracking that. So if I take the board, and just so you know, I had the soldering iron out and ready. I was going to solder and try and burn myself tonight, but we're not going to get to that point yet. So if I take the little board, so again, this is the sled for the board. We're back to the battery pack now. So this is going to go in here like so. Okay, we're going to do the draw in about 3 more minutes. Then we're going to take that little M3 screw and we're going to screw that in through there like so, and like that. There, that's good. Yeah, so that little M3 screw right there is going to hold that board nice and tightly in place. So that's a nice little add-on to do to that. There we go. So that's going to hold this in. I mean, that is snug now. I can plug a USB in and out of there all day, and that board's not going to move for sure. So, yeah. So let's see what happens if I plug a USB-C into here. That's under 5 volts of power. There we go. Oh, that one's got a, this particular board has an LED chip that's out. Does this one? Let's just check this one. No, this one doesn't. There we go. That doesn't have a chip out. See, we 100%. That's what you get for buying cheap boards. This one here, it's going to flash for a couple, then it's going to stop. No, might be defective. Yeah. But we know they work. There we go. But yeah, that works. So we can now print this sled, no problem. We're going to do it on the. Let me take this off. We're going to do it on the Elegoo Century Carbon, since that was the one with the best tolerance. And all I got to do now is change the position of that window for the LED slightly. So good. So we know that works. Adding that hole. That should have printed right to the bottom of that sled, but for some reason it didn't. I've got a little bit of a gap in there, but that doesn't matter. It's still strong enough to hold it. Didn't need to go to the bottom of that. I guess we're fine. Okay, cool. Okay, so let's put that M36 back in the drawer. We know that that's what we need. This is potentially a defective one, so we'll just throw that aside. We got lots of them. Okay. Oh, you know why? It's probably because I have to solder the temperature sensor together. Is probably why it was giving me that flashing error. Okay, it makes sense. Oh, what a mess. What a mess this all is, huh? What a mess. What can I tell you? Let's do a draw. Let's give away some filament. What the heck? If you haven't entered, it's too late. I'm going to shut the draw down. Okay, and then when we're done the draw, I'm gonna try something else really cool with a little toy for these batteries. So we'll try something else when we get that down, and then I'll get my poop together through this week and figure out what's going on with the assembly of this, and I'll try and get this sort of all sorted out so that I don't make it look like a circus show when I'm trying to get this assembled. So. But that's the beauty of live stuff, is I don't pre-test everything. Everything you see is me doing this for the first time, so the struggle is real, as they say. So, okay, let's go do the draw. I'm going to go get that, close that the Google form off. We're going to shut it off. We have 50 responses, which is great. You got to be here to win. That goes without saying. So let's go ahead and download the responses. Download the responses CSV. There we go. If you haven't entered, it's too late, so sad, too bad. Okay, we're just going to minimize this. We're going to grab that spreadsheet I downloaded. There it is right there, and we're going to open that up. Boom. And I just need the YouTube name. Oh, DeWitt's in there, so let's go ahead and sort this. See if anybody entered twice. Data. And I want to sort. Where's my sort? Data. Data. Stay tuned. Sort. We'll sort by YouTube name. And let's see what we're doing here. Come on, where'd you go? Where'd you go? Okay. Oh, come on. What? Why are you giving me trouble? Sort by column. Okay. I can't tell if there's... Why is it not letting me sort? Okay, let's do that. It's giving me a hassle with the sorting for some reason. Sort. There we go. YouTube name. There we go. Okay, now we're going to see if there's any duplicates in here. So far we're good. Oh, there's one duplicate. Now, I'm not going to say who it is. I'm just going to say, you know who you are. That's okay. And let's see, one duplicate. We don't want DeWitt in there. I just put my name in there as a test. And let's see. Oh, there's another duplicate. You know who you are. We'll delete that duplicate. And let's just keep going. Let's see, let's see. Two duplicates. That's not bad. Only 2 people cheated. That's not bad at all. Entries are void without likes. Exactly. Anyways, only two people duplicate entries. That's okay. But we caught them this time. One of these days I will say you're banned. If you enter twice, you're banned. But that's pretty harsh because sometimes it's just by mistake. Okay, let's copy this. So we officially have 48 entries. And we'll open the spin wheel thingamadoober here. And where are we here? There we are. Duplicate entry should be disqualifying. Well, we're giving a few weeks grace period there, Tuxedo, just to be sure. Nick, I've had a hard time remembering if I entered before. Yeah, nice, likely excuse. Okay, let's go to the giveaway page. Here we are. Okie doke. First thing we do on the giveaway page is we spin the wheel to see how we're going to do, how many spins, etc. So let's go ahead and spin the wheel. This will tell us. Dun, 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 dun. This will tell us what we're going to do for spins. Da, 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 da. We are going to shuffle 6 times and spin for 15 seconds. I know, pray it doesn't fall on 200. Shuffle 200 spins. I put them in there for fun. No, the giveaway song is gone for now. I might come up with some new ones, but there was some copyright issues for some reason, which there shouldn't have been, blah, 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 blah. Anyways, shuffle 6, spin 15. Okay, we're on 15 seconds. We're going to shuffle 6 times. Let's get rid of all this stuff that's on the wheel. Boom, gone. And let's go ahead and paste in everybody's name. Okay, there we go. We're going to shuffle 6 times. Ready, set. 1, 2, 3, 4, 5, 6. And a 15-second spin. Good luck, everybody. Here we go. Spin 1800 would be fun. Yes. Oh, man. That would take up the rest of the stream. And the winner is... Yay! Yet another dad. Yet another dad. Congratulations. Are you in chat? Yet another dad. Say something. Say something right now. Congratulations. Yet another dad. Let's go, thanks. Awesome, yet another Dan, yet another Dan. Did I say dad? Yet another dad. Yet another Dan is here. Congratulations, yet another Dan. I am going to let you stare at that wheel for a moment whilst I send you the winning email. So let me check it out. Bear with me one momento. I'm going to get your email address from the list. You too. Oh, come on, come on, come on. I love spreadsheets, but sometimes, okay, here we go. Where are you? Where's your name? Where's your name? Glad there's not like 300 to show from. There we are. Yet another Dan. I've got your email. Here we go. Boom, 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 boom. We're going to copy that. Oh, that's not what I meant to do. Copy, not paste. Copy. Let's go to my email. Type in your email address. Boom. And 1 and a 2 and a send. Okay, yet another Dan. It's on its way to you. You should receive it within 10 seconds. If it doesn't get there within 10 seconds, there is something wrong. Jeff was 1 femtometer away from winning. We needed 16 seconds. Oh, look at that. You guys, come on. It's always going to be, you're always going to say, we needed 16 seconds. Oh, we needed 12 seconds. Oh, we just needed 11. Oh, one more name and it would have been me. Ah, what can you do? But congratulations, yet another Dan. It's nice to share the love and spread it around. So there we go. So until next week, boom, we're back to this window. Congratulations. Okay, so let's just do. Oh, I was going to ask you guys with battery knowledge. Okay, so here we go. Somebody who knows something about batteries. You might be familiar with something that looks similar to this. Okay. This is a Ego 56 volt battery for my Ego brand tools. Okay. Great batteries, great tools, etc., etc. Neres was in chat. Was Neres in chat? Oh, well, Neres, if you're in, Chris, if you're in chat, then you know you got to come by next week, and we got to discuss assembling this light a little bit. If you're still in chat, Neres, oh, you're in chat. Okay, well, question for you then. While you're in chat, we'll show this battery off. Well, let me talk about this real quick, then I'll get back to your flashlight question. Or my flashlight question about your flashlights. So this battery, I went to charge it one time and it gave me an error. And when I pushed the charging button, or the charge button, it was red flashing light. So to me, it's an error. Those batteries aren't cheap. Inside those batteries, inside this battery is this. So when I push this, it gives me an error, a red error, and it's just going to flash, 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 meaning that the battery is kaput, according to the legend. When it flashes that red on the legend, where's the legend on here? It says flashing red flashing. It tells me somewhere, but that the battery's kaput. Now you open this thing up, and this thing is made up of, I can't even figure out how many, but probably 50 or more 2.0 amp hour, 7.2 watt, 18650 cells. Is there any way to fix this? I mean, there's a lot of crap in here. These are all, obviously, these are all hooked up in series to make them 56 volts. Try to reboot it. How do you reboot a battery? Basically, you're holding a bomb in your hands. I am? Oh my goodness, no. How do you reboot a battery? Because this thing was only a year and a bit old. So, yeah, because these companies have something to sue, there's a lot of safety protocol built into a battery to keep it safe. Yeah, 20 seconds, hold the button. Really, 20 seconds? Okay. 1, 2, 3, 4. Oh, now it's flashing some weird colors. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's what's going on there. Now it's just flashing green and red. Oh, it stopped. If I push it again, we're just getting the red flashing. Notice they pot it well so you cannot disassemble it exactly. One dead cell, because if I meter this, okay, so if I go ahead and meter the battery, and I believe that was positive over here where the red is, so you guys can see the meter right next to the battery here, right there. If I meter the battery, if you look, we have 51.1 volts. So we have 51 volts coming out of a 52 volt battery. So the voltage is right, but I still get that error. So it just, the voltage is down a little bit, meaning the battery needs charging, right? So anyways, test each cell. But they've got this thing so tightly mixed together that if I take it apart, I'm afraid I would never ever get it put back together properly. But and I'm thinking, okay, is it cheaper for me to buy, I don't know, 50 18650 cells, or is it cheaper for me just to buy a new battery pack from them? Like, it's crazy, because these things are not cheap, these battery packs. Is the voltage right? What is the low voltage cutoff for the battery? I don't know. If I'd count the reset time slower and always give another couple seconds, what happens when you put it on the charger? Nothing. You get the flashing red on the charger saying it's not, it's an error. Okay, let's do the reset one more time. Then I got a question for Chris. Let's hold that for 22 1000, 3 1000, 4 1000, 5 1000, 6 1000, 7 1000, 8 1000, 9 1000, 10 1000, 11 1000, 12 1000, 13 1000, 14 1000, 15 1000, 16 1000, 17 1000, 18 1000, 19 1000, 20 1000, 21 1000, 22 1000, 23 there's 25 1000s. So if I let it go, it'll stop flashing in a second. And then if I then test it again, yeah, we're red. Okay, I just wanted to ask your opinion on it. Yeah, there's a lot of, like, on the bottom of this, I don't know what these little individual wires are for, other than testing each individual cell, but I guess if I can get it apart and possibly take out and test it. If I can find the cell that's wrong and I can get it put back together, then that'd be fine. But yeah, just search on YouTube. Lots of ways to get it going. Need to trick it into trickle charge. Ah, okay. Yeah. Okay. Placing on. Okay. Well, we'll Google YouTube it and Google it and see if we can fix it. I just thought I'd throw it out there and show you what I'm working on or what I'm after right now. So. Okay, back to my question for Chris. You're still on here. So we're working on your light. We finally got the battery. I got the negative terminal of the battery in, but idiot me didn't bother hooking the positive terminal of the battery, the wire, up before I put it in. So there we go. So we're gonna end up taking that out anyways. So we'll take the, and I used hammerhead screws because I didn't have any proper screws to fit this, but it would work just fine. So let me take this terminal off. Let me get this terminal switched off. Terminal connector, because it's tight in there. There we go, and then I can pull the battery out. There we go, and I just got to remember. So putting the battery in is no problem. We're using a, I believe it's a pretty heavy gauge wire, like you suggested. But, so in the instructions that I wrote down metering the battery, which is fine. We know that on these batteries, the top where the label is, this is plus and this is minus. Okay, so we figured that out. And then we have battery to the BMS. Okay, so we have the BMS here. Oh, where's my, there it is. So we have the battery to the BMS, and so the BMS in, which is the square pads, okay, which is these outer square pads here, okay. Then it says BM out, which is the oval pads, BMS out to the PD trigger. This is the PD trigger. Okay, this is the PD trigger. Now, according, the two square pads for the battery go to round pads with holes go to the USB-C port. Oh, okay. So when this says BMS out, the oval pads to the PD trigger, I gotta go into the USB-C port from that? Is that correct? And then out from the PD trigger is the green. So I go from the PD trigger out to the switch from the green. No, the green junction block. Okay, so I'll go into the green junction block. Okay, so I go into the green junction block from the BMS. Is that correct? Okay, so I'll go into the green junction box from the BMS. I'm just going to make sure that's correct. I know you're typing. And then, so if I go from the BMS out to the green junction box in the PD trigger, but then it says PD trigger to the switch. Where do I go out from the PD trigger? Oh, it's not posting all your comments. Oh, weird. Yeah, but I'm going from the BMS into the green, but am I also going out from the green to the switch? So does the in and out go to the same thing on this? Okay, so into the green from the BMS and then out from the green to the switch. Okay, that makes sense. Okay, out to the switch as well. Two wires in the green junctions. Okay, okay. If you use a period, it might not post. And I don't think I have slow chat mode on. Okay, thank you, Chris. That clears things up perfectly. So I can actually have two wires, and I can put a ferrule, two wires into a ferrule, put the ferrule into the green junction here, and one set of the ferrules is going to go to the BMS out, and the other set of the ferrule wires is going to go to the middle section of my switch. Okay, that clears a lot of things up. Okay. That makes perfect sense. Thank you. and the jumpers, whoops. I just leave the jumpers as they are on this. Is that correct? Hang on, let me see. So we have three jumper pins. Right now they're all on off. And so I just leave those jumper pins in the off position. Is that correct? Yeah. Dip switches. Yeah, that's jumper pins, dip. Oh, yeah. Assumption is the mother of all F-ups. Plug a charger into it. Put a meter on it and make sure it's 5 volts out. Oh, okay. Okay, so you're saying take a 5-volt power, which is what I've got here. I love what you said there. Mother of all assumption is the mother of all F-ups. I agree. Okay, so let me go back here. So you're saying plug this in, because this is 5 volts out. This is plugged into 5 volts. And then grab my meter. Okay, we have a light on, so we have power coming out of this thing. And so grab my meter. And where's my positive on this one? It's going to be... Which one's my positive? Oh, okay, ground is the one on the right. So we'll turn the meter on. Here, actually, let me put it overhead so you can all read the meter, in case I electrify myself. I won't electrify myself with 5 volts, but okay, so ground. So this is the ground. And, oops, I can just do it like this. Ground and positive. 5.05 volts. There we go. So we have 5 volts coming out, so we're good. Yeah. Can I link you a USB tester on Amazon? Can you link me? I guess so. Do I need it? You have to connect it with a real 20 volt capable source to test 5 volts out. Really? Oh, I see what you're saying. Well, we got 5 volts out when we're plugged in with a 5 volt doomer thingy. But if we're going to go, well, this is going to be the charging port, and we want to make sure that we're not going anywhere than 5 volts to charge it, and we're going to charge it with this. Yeah, okay, I should be fine. Yeah, because this is how we're going to charge the light, is with the 5 volt USB-C cable. So, and for as long as we're getting 5 volts out, that's fine. I guess the dip switches then adjust the different voltages out. Okay. No, that's not a charger. No, this isn't a charger, but yeah. But yeah. Oh, it's not a charger. You don't need it, but it'll make things easier when testing. Okay, all that is a trigger that simply tells the charger what voltage to use. Oh, okay. And what is the actual charger? The BMS? Battery maintenance BMS? Is the BMS what actually charges the battery? I'm not that versed on electronics, as you guys can tell, but I'm learning as I go. The BMS is the actual charger for your lithium iron phosphate cell. Okay, perfect. Okay, let me look at that Amazon link real quick. Here, let me switch back over to my ugly mutt here. Hang on, there and there. There we go. Let me look at that Amazon link. Reply. Let me see, where is it? Why is this? There we go. And, oh, look at that. USB-C tester meter. Oh, I like that. Okay, well, thanks for that link. I will look at that. Perfect. Your BMS is what needs 5 volts. Okay, makes sense, which is why we go, yeah, okay. Battery management system. Does the 5 volt input come from the PD charger? If you plug it in a dumb 5 volt charger, it will work fine. Okay, I get it. Okay, perfect. Okay, awesome. So we're gonna work on that now that we got Chris to clarify that. Thank you so much. We're gonna work on that. What I think I will do, since I have so many parts here, I have way more than enough parts. I got the heat sinks, by the way. I've got the heat sinks, everything ready to go. We need some really thin wire for wiring up these LED plates, because once we put them in, where did I put that? I've got so many things spread out here. I don't know where I've put anything. I bet it fell. I bet it fell over the edge. It did too fall over the edge. Let me go grab it. Let me go grab it. Ugh. I gotta go grab it. Oh man, I dropped a few things. Holy crap. I dropped that. I dropped a BMS. I dropped this. I dropped this. Holy crap, look at all that stuff I dropped on the floor. Woohoo, we having fun? We're having a lot of fun. Does your power brick give you 5 volt a PD capable charge? I don't know. You mean this power brick I'm making? So the LEDs, where are they? This will go in here. Now the wire's it's got to be thin wire, because if this LED is going to sit in here, like so, and then the other LED is going to sit, where did I put the other one? It's here somewhere, right here. This is going to sit in here like this. We got to wire these two together. Then we have to have wires coming out. Probably have them come out the middle. Then we have a heat sink and a heat sink, like so. Okay, and then we have this guy, which will screw on to this like that to hold it all in. Then we'll have the wires coming down from the top on this. Come out the middle between the heat sinks. That's part of why it's TPU. The wire will get squished. Yeah, okay, perfect. Yeah. Yeah. And I'm using thin, I got some nice thin silicone wire for that to come out of there. For these, some black and red here to come off of those LED plates, pucks or whatever you call them. So we'll be using that, and then I've got the heavier gauge for the battery, for the higher end stuff we need. And I got so much junk out here, and I even had my soldering iron out ready to solder tonight and burn myself, but it's not going to happen right now. Everything else, everywhere you want the power withdrawal, is almost non-existent. Yeah, exactly. So that's going to go there. This little guy, this little PD, will be sitting in here, like so, right there. And then we have a little thing to screw it down to hold it in place. And then he's also got this little guy here, which is going to hold that in place just nicely so that when you push the USB-C in, it's not going to push it out. So that's what this little guy in here will do on top. Okay. That's just going to hold the board in there just perfectly nice. So that, yeah, anyways, trust me, it will. And then then we have the switch, which is going to go in there. So we're going to have to run, the wires are going to be a little longer because we got to take it out to solder it and then we run it in, but there's plenty of space. Once the battery's in, there's plenty of space in here for all the wiring and everything, even for the BMS. I don't believe there's a mounting point for the BMS. I think the BMS just kind of sits in here. Don't be afraid to use excess wire. That's why I made the cavity so big. Exactly. So the BMS can hang out in there. Should I shrink wrap the BMS after I wire it up so nothing shorts? I guess I could. And then we have over here, let's get one of these LEDs out. Over on the side is where we have the side LED right here. And this slot, what's this slot here for? Is that the BMS slot? No. No. Not sure what that slot right here is for. Is there something I'm missing that's going to go in this slot? Okay, shrink wrap the ends and leave the MOSFETs exposed. Oh, makes sense, yeah. Okay, that way, keep the MOSFETs open, just shrink wrap the ends where we have the actual wiring going through. Makes sense. Not a problem there. Just wondering about this little slot. It's so the wire from the LED can get inside. Okay, perfect. Could actually print a little cover over that actually afterwards too, possibly, just to sort of cover that up. I'll have a look at that. But yeah, that's, other than that, I think that's answered all the questions. Then we have the LED drivers in here. So we have two of them with a potentiometer. We can measure the voltage coming out of those. I haven't figured out an elegant way to do it just yet. Yeah. There we go. Perfect. Oh, that's good. That answers a lot of questions for me. We'll be able to get this assembly started next week then. What I'll probably do during the week is I'll probably print a couple more flashlight bodies in different colors because I want to make about 4 or 5 or 6 of these because I did bring in oh, don't fall. I've got 1, 2, 3, 4, 5. Why are you doing that? You're not supposed to do that. I don't want to leave the site. Browser warning you just saw as part of your safety. Oh, stop it. So I've got a few batteries. So I got 6 of these. So I can make either 6 lights or I can make 4 lights and 2 of your power banks. So I haven't decided yet because I'm making a different kind of power bank as well. We're doing these power banks here with this little module, and then this goes in a little sled like this, and this little module slides in, and this uses 2 of these 17 or 21700 batteries, and then this power module slides in, and then we have a charger here with a power level indicator. That's the other thing we're working on here. So, but I've just got to redesign this slightly so that this window is over just a little bit more. So that's everything we're working on here. It's a lot of stuff. It's a lot of mess. It's a lot of everything. What can I tell you? Yeah, I think I do want to do one of the power banks as well. So I'll probably save one of the batteries, one or two of these batteries, to do the power bank with. So, yeah. But I did discover the top is positive on all of these is where the label is. Those were all tested, so that's good. Power bank is from someone else. This power bank is from someone else, but Chris did on his site Nearies. He does have a. I don't think it's on printables yet, but he is working on a power bank that uses this battery. So yeah, so that's another thing to look for, and I probably will end up building one of those because I just love this electronic stuff. I don't understand it fully, and I learn as we go, but I'm loving it. So there we go. I'll be a little more organized next week for this sort of things, and I'll have. I'm going to actually print the ones I'm going to do for this. I'm going to print in this Power Tool green. I love this color, Power Tool green, so we're going to do that. Oh, it's on printables now? Good, good. Okay, I wasn't sure. I don't think it was on Wednesday when I was chatting with you, but that's good to know. Well, that's a lot to cover for one night, and I learned a lot in one night, so I want to thank everybody for being here and for all your patience and everything like that. Yeah. I'll be interested to see. You know what? It'd be interesting to see with this power bank, which is going to end up being, these are 3.7 lithium, and they're going to, because they're going to be in parallel, they're going to be 10,000 milliamp hours in total, because these are two 5,000 milliamp hour batteries. It'll be interesting to compare the power out of that to the power out of yours, and just to see the comparison and see how they compare. I think they're both going to be great. So PD charger can deliver up to 5 amps at 5 volts. Wow. Very cool. You're having a lot of fun. Awesome. Could be any power tool that rhymes with Toby. I think I have another power tool color too. Maybe I'll do 2 different ones. I got to check and see. I'm pretty sure I have another power tool color in this high temperature PLA. But I love the surface finish of this. I love everything about this. So you were asking you were asking insistingly about the wattage for the LEDs because the current draw is very important, but it should be fine. The wattage draw on these LEDs. So I think I did that last week. Here, let me just do that really quick before I close off here. Let me plug in my. If I can get it out of this mess, I've got my my bench power supply here. Let me plug this in. And let me go. So what are we going to be getting on these LEDs? We're going to be getting 3.2 volts. So 3.2, turn this on. Let's switch over to here. Whoops. Why is this not coming? Oh, helps if I actually plug the power into the power outlet. So we're going to go 3.2 volts, did I say, for these? That's what the batteries are putting out. So 3.13, there we go, 3.23 volts. We'll grab one of these pucks. Okay. 5 watts, but I don't think they achieve it. Okay, so let's see. We go positive. This is going to get bright. These are very bright. And negative. Oh, that's bright. And so we're looking at 3.4 watts, 3.9, 4 watts it looks like. And I think they're all consistent. Where's the other one? Where's the other little guy? Where did I put the other one? I've got such a mess here. They should all be the same, but it looks like 4 watts. Here, I'll just grab one of these. Let me just grab one of these. There we go. And positive, negative. There we go. Yeah, so we're looking at about one amp and not quite 3.5 watts, something like that. You can kind of see what's happening there. Although the amperage keeps climbing a little bit, the more I hold it on there. But we're under 4 watts. Oh my God. 1.2 by 3.2 is 3.84 watts, which is about right. Which is about right when you look at that. 3.5, 3.6 watts. So that's about right. But they're so bright. They're so bright to look at. They get a little bit warm too. Cool. Hence what the heat sinks are going to be used for. Right, there we go. So let's turn that off. Let's unplug this. There we go. Okay. Well, we went a little overtime tonight. A little bit overtime. Doop. There we go. Perfect. That's because there's no heat sink. That's why the current keeps increasing. Yeah, because there's nothing to dissipate the heat. Ah, those wires will be able to handle it just fine. Perfect. Perfect, perfect. With proper heat dissipation, resistance stabilizes. Resistance is futile. Put these on it and resistance is futile. There we go. Okay, guys, listen. Thank you, everybody, for joining me tonight. If you're still here, awesome. Thank you so much for sticking with me through this whole thing. I got that from you, just so you know. Oh, my goodness. That was the Borg. Look at that. Anyways, resistance is futile. You guys, thank you so much. Chris, thank you for being here and clarifying those things for me. That is awesome. I'll see you on your stream on Wednesday. We'll continue this next week. It'll be a little bit more organized next week, I hope. I'm going to reprint the casings for this other power bank that we're going to do. I'll print a couple of these casings. I'll fix this window position so that we should be ready to go with this. Yeah. And otherwise, that's everything for tonight. Thank you so much, everybody. Appreciate everybody being here. Is that the glass fiber filament? Oh, actually, real good question. Was this GF? It is. Oh, that's why the surface is so nice. This is the, I didn't even realize that. That's this filament right here. PLA glass fiber, power tool green. There it is, right there. I didn't even look to see if it was the glass fiber, but that's why it looks so nice. Oh, that's why it tastes like glass too. That's cool. Yeah, that is. Very cool. Okay. Oh, you guys. It's from the original designer of the positron. Very cool. Yes, you're the man, you licked it. Always. Okay, I do some weird stuff. Anyways, guys, thank you so much for watching. We'll catch all you guys next week. See you Wednesday, Chris. And everybody, just have a great week. And come back next week for some more fun and licking filament, I suppose. We'll see. Okay. Bye, guys. Talk to you later.